Welcome to the last and final lesson of Chapter 10, Measuring Distance with the Equivalent of a Triangle. Chapter 10, Mastering the Concepts of Triangle Congruence and Using those concepts to solve real-life problems. Learning Goals. Review and summarize the judgment of the properties of triangle congruence. Is able to measure the distance between 2 points according to the triangle congruence and solve real-life problems. Introduction. What are the necessary conditions to prove that two triangles are congruent? You should be able to list at least 4 of these down because we've been learning all about these in the previous lessons. The first one is SSS. Two triangles 3 equal sides are congruent. ASA. Two triangles with 2 angles in one of their sides are congruent. IAS. Two triangles with 2 equal angles in one equal side is congruent. And the final one is SAS. Two triangles with 2 equal sides and 1 equal angle is congruent. 2. What are the properties of two congruent triangles? 1. The corresponding sides of a congruent triangle are equal. 2. The corresponding angles of congruent triangles are equal. Measuring distance with the equivalent of a triangle. Activity and experiment. Watch this experiment. So this, I'm going to outline this so to make sure that you know, is a person. As you can see, he has this baseball cap on his head. From the tip of his baseball cap, it's pointed straight towards just the base of this castle. Then he turns around. Remember, this is still the same person. And he doesn't move the angle of his cap. Instead, it just happens to land at the base of this tree. So then, the interesting part is here. This part from his feet to the base of the tree is, so this would be the distance of the tree. The distance to the tree would be equal to the distance to this castle because he stayed at the same place and he turned his baseball cap to the base of this castle. Then he turned around. Remember, he didn't take any steps. He just turned around. And then, without moving the angle of his cap, he saw that it landed exactly at the base of a tree. So, it means that the distance to the castle is equal to the distance to the tree. What are the equivalent quantities you can find from these steps? Try. As shown in the picture, a worker wants to calculate the volume of a cylindrical container and needs to measure its inner diameter. Now there are 2 wooden sticks of the same length, a rubber rope, and so a rubber band. This should be a rubber band, that makes more sense. Band and a ruler with graduations. Can you help him complete the task? So there are 2 equal wooden sticks. So these are the 2 equal wooden sticks. So as you can see, I should talk to you about what this is first. This is a cylindrical container. From the side, that's why it looks like a rectangle, but really it's a cylinder. So this is its inner diameter. Remember, the diameter, since this is supposed to be a circle down here, is the distance from one point to the opposite point on the circle. So that's the length. This is the diameter. I'm going to write a D for that. So this is what he is trying to find out. Then, let's see if we can use the experiment we just learned about with the castle and the tree to solve this problem. Now there are two wooden sticks of the same length. Okay? So we place this wooden stick at one point of this cylinder at the side, and then it stretches out. This is the midpoint of it, midpoint C. Then we take the other equal wooden stick and place it at the opposite point, intersecting it, also at midpoint C. This length between these two sticks right here is the same as this diameter. So this is how this can be found out. 2. Standing alone in the middle of the road, a man looked to the left and then to the right, and then said that he knew that the monument was as high as a 5-story building. Do you know how he did it? Okay. Well, how did he do it? Pretend this is on a number line. Not on a number line, but something like one. So just something that measures distance. This point is where the person is at. Over here is a monument. And over here is the 5-story building. And how did he find out? Well, standing in the middle of here, he has something on his head. It could be, say, another baseball cap. And he looks up to his left and sees and keeps adjusting his cap so that it aligns with the very top, the tip of this monument. Then, without changing that angle, he turns around and he sees that at the same time it lands just near the very top of this 5-story building. So that's how, remember, he does not change the angle of his baseball cap. So that is how he finds out. The height of the monument is the same as the height of the 5-story building. And remember, this person has to stand right in the middle of these two buildings, not closer to one of them, or, yeah, so he has to stand right in the middle. So what are you starting to observe now? Well, you may have started to notice that it's a congruent triangle. Here's how we can find that out. First, we know that he has to be standing in the middle, so this must be the midpoint of this line segment, which also means that once you see these two smaller triangles over here, their base line segment has to be equal, because he has to be standing in the middle of this line segment. Also making that this angle is the same, because he never turned and shifted the angle of his baseball cap. It means that these two angles are the same. And again, we know that these two angles are also the same because they're 90 degrees to the ground. So, therefore, that is how we can find out. Knowledge and facts. The purpose of using triangle congruent distance measurement to change the unmeasurable distance into measurable distances. Here's the basis, the nature of congruent triangles. The key is to construct a congruent triangle. The procedure is, first, extend to construct the congruent triangle. Then, the perpendicular method constructs congruent triangles. So we always know that the building is going to be perpendicular to the ground, so we know that that's 90 degrees. Mathematical thinking. Establish the idea of using triangles to construct mathematical models to solve real-life problems. The two skills we learned today was review and summarize the judgment of the properties of triangle congruence. Is able to measure the distance between 2 points according to the triangle congruence and being able to solve real-life problems. So I hope you enjoyed learning all about triangles, especially the ones that are congruent in chapter 10. And see you next time.